So, mi hanno detto di cominciare.
Sì, io stai là.
Yeah. So, good morning, everyone. Thank you very much for being here again. And being with tonight, but Italian we use a lot of our answer when we talk. Okay. And today the presentation will be just a different from yesterday, and we will start with an overview of activities in robotics that we carried out in Antarctica and Arctic during the last 30 years, 32 years. And then also following this, what we see in these applications, we will talk about the importance of the way of introducing data in robotics, and then on the possibility of so, okay. Yes. Okay. So, inconvenience, and as we introduced yesterday, polar robotics played a key role in the history of robotics because the first autonomous underwater vehicle was built to handle the curiosity of scientists in the art. And the problem was the topography of the tactile underwater profile. In the case of the Fletcher Ice Island, also called with the short, it was a huge iceberg that moved inside the Arctic region, as you see here, close from Greenland, Canada, and Alaska. And this is the cyan one, is the path of this national. And it was so large that scientists mounted a research station on it. And of course, stay there, you are interested in knowing how is the conformation of the ice below the sea, under the sea, and see basically the other phase of the art. And so the problem was to map the topography of the tactiles. And the solution that they thought was to use underwater vehicles equipped with acoustic sensors. Something similar to what we tried to do in front of the tomb of the company just in Antarctica, but we tried 20 years later. And the University of Washington's Applied Physics Laboratory developed what a manned Arctic research submersible that you can see the top bottom right of the slide to explore the field of the Fletcher Sea. And there was a strong technology challenge for doing that. Because the only thing they could do was to deploy the EUV from a hole in the tactiles, and they had to launch the vehicle had to move in a transit for a long path, and then come back and be recovered. And here we see that when you use an EUV, you have a first problem that is to deploy the vehicle, and then at the end of the mission, you have the biggest problem that is to recover. So, how could the vehicle go back to the launch and recovery point after a 17-mile transit? The solution was to deploy an acoustic transponder in water in the hole to the same hole where the vehicle was deployed. And they mounted two acoustic directional receivers on the vehicle bow and one omnidirectional acoustic receiver on the vehicle stack. This means that when the vehicle was moving away from the launching hole, it could measure its range from the hole. And when coming back, having two acoustic receivers, it could not only measure its range, but also its the direction of the target with respect to it. And to recover the vehicle, the solution was to deploy a net inside the water in that area, and then the vehicle moving forward was recovered. And the system worked. They didn't lose the vehicle, and then the transit, the presentation of the topography of this Some years later, almost about 20 years later, the Odyssey EUV that I already introduced yesterday was used in the Arctic. It was at MIT, and Jim Bellingham was the leader of this expedition. And today we are dealing with polar robotics, and we see the first way of working that was quite typical in the Arctic, on the tactiles. Basically, they mounted the tent to protect the surface operating station, and in this way you can easily keep the vehicle, the computers at a reasonable temperature. And also a question that people usually ask me when talking about these situations is what about the cold temperature and so on. But if you are protected when you deploy a recovery vehicle, it's not an issue. Also because the temperature of the water is -2 degrees, so it's quite constant and not too cold. The problem is when you're operating, if you operate from a support vessel and you have to keep the vehicle as soon as once you recover it from the water, you have to keep it on the deck outside. There it could be quite cold, it could be quite windy, and so you could have temperatures that are quite low, and you could have some risk of the electronics. And you see also something else, this wooden tables. The because when you make a hole in the peptides, what happens is a strange phenomenon, because the seawater corrodes the ice just around the hole. And basically you have a shape that is basically you have the ice, but then it goes inside and then goes outside again. So it gets thinner and thinner in the proximity of the hole, and it could be quite dangerous because it breaks under your heavy, and then you weight, and then you can go in the water, and it is in this situation very dangerous for your life, not for your life. And so a typical solution is to mount, to position wooden platforms around in order to distribute the weight and reduce the distance. When I'm working in Antarctica, Italy has a station, usually we call station the scientific basic infrastructures that are open only during Antarctic summer, and base the ones that are open during all the year. And it is in Terra Nova Bay, in the Ross Sea. Basically, when you talk about Antarctica, probably you talk about Antarctic Peninsula and USA. In our case, we talk about the Ross Sea, that is just south of New Zealand. And here there is the big station, big base, the US base of McMurdo. This is Terra Nova Bay, in the US area. And there is in this area there is a French base of Mondovino on the coast, just south of Tasmania, and approximately in this place we have a base, Dossi, base Concordia, that is shared between Italy and France. But when dealing with our activity, it was in Terra Nova Bay, now we call the Barrio Turcali, one of the Italian pioneers in Antarctica. And in 1993, under the pushing of my first head and mentor, Gianmarco Perugio, we brought the first Italian ROV in Antarctica. It was gone through. We see some preliminary operation from the pier, and it worked also from a support, from also the iceberg, and from the support vessel management. And the activity was to support the proposal of an Antarctic specially protected area, number 161, in Terra Nova Bay, that after some years was approved. And the use of the ROV was to monitor, to show what there is under the peptides. And it is something that could surprise you, because when you are on the surface, it is basically a desert, a white desert. But when you go underwater, it is full of life and colors. And we will see also later. And from the point of view of the logistics that we used, it was the classical logistics, with the tank, the hole, the train inside, all the computers, and so on. 4 years later, in 1997, with the Romeo ROV, that was the one I showed yesterday, we developed in parallel to Ifremer toxic powder, we had this prisma flow that was consisted of what we call 3 legs. In the first one, we made under ice monitoring, performance evaluation of acoustic instrumentation in view of the building of the entire Antarctic AUV, and then underwater monitoring from the microscope. In this picture, you can see the utility of the interference cable tools. You see that this can be connected this magnetic mechanism to the body of the tree. And here in this case, for instance, we see a Platon center that we developed for this period. And so we see some operations. Here we are on the ice stacking the proximity phase. You see all the floor covered with black ice to isolate from the cold, but also to reduce the risk of going to the water. And in any case, it was necessary to move the camp after 7 days from one point to another because of this corrosion of the ice. And these are some images that we could collect with the ROV below the packed ice during the campaign. And there were, especially during the first period, there were a lot of medusa, and here we are in a small bay that is in the proximity of our station. These images are, as you see, we are very close to the packed ice, and with the ROV it was possible to follow them to collect this. This is the seafloor, where the Antarctic silverfish. So, and go just a bit home. No. No, but I don't, sorry for I made a mistake with this. I don't see it there. I'm sorry for that, Nicolas. I can try here. It doesn't work now. Sorry for that. It doesn't work yet. Sorry for this inconvenience. Okay. No, go back to the movie, please. Go back. Okay. Okay, can you start it? Okay. Okay, and can you move it just a bit forward so we don't see it again? Okay, perfect, yeah. Yeah, thank you. But we don't see it. Sorry. In any case, there is this fish, is Antarctic, so-called Antarctic silverfish, and it is at the basis of the alimentary chain in this area of the world. And it is studied, and what scientists don't know is how it reproduces. Okay, you see, we don't know how it reproduces. We will see also later in some other research carried out, because we find the eggs and larvae of this fish in the packed ice. But this is Agamucium cordaceus. These are scallops, and there are a lot of them. Here you see a seafloor not covered by Agamucium cordaceus, and this means that it is different. And now you see all this kind of snow. This is basically these are nutrients, and this means that we are towards the end of the campaign when Antarctic spring is starting. And you have here also a short view of operations from the support vessel. And this day, so now we are in February, so we are very close to the Atlantic summer, and you see that there are a lot of nutrients falling down, and it is possible to see them. And in any case, the life that we have underwater is completely unexpected. At least for me, I'm not a biologist, so let's say for an engineer to see this desert on the surface. And in any case, we had also interactions with the local fauna. And what we saw is that seals are very interested by the robot, and they like a lot the cat. And we saw when we had all the days this seal came to the hall, stayed there, look at us, and so our feeling was that we were in a zoo and we were in the park of the animals to be visited by the visitor that was the seal. And it was very interested to the people, explore deep and so on. But in any case, you have also to take into account that they can do disasters. And when dealing with Antarctica, and you work in Antarctica, in many cases, you can listen that Antarctica is seen as a nice place where to test space technology. Because basically it is the place of the Earth that is more similar from the point of view of isolation, difficulty to reach it, and so on. So when starting to prepare the Mars missions, NASA during the 90s performed satellite-based teleoperation of the now being fragment of sound in Antarctica from NASA Ames Research Center in USA. This was the way they had on the Earth to test something at field with delays in communications and this teleoperation with delays that were not generated artificially by human beings, but that are linked to the natural system. And so basically Antarctica was used as a space robotics training ground. And following this idea that teleoperation, satellite-based teleoperation was possible, what we did was to propose and check internet-based satellite teleoperation of the rover in Antarctica from CNR headquarters in Peru. And then we followed that. Also, we did it also in the Arctic, in Svalbard Islands, where there is an international research base in New York was an old mine town that was closed from the mines due to terrible accidents in the 60s, and then it got to the center of an international research place where there are stations of many states. And the Sierra is the Italian one. And Neosund is the village inhabited during the whole year that is most north in the world. And in the case of Neosund, we teleoperated people and also marine scientists who teleoperated the people from Norway, Scotland, and Naples. And also in this case, as we worked with the rover from a farm, that was the small support vessel located made available in Indonesia, and to explore and see what there was underwater in the console. And this was the first time we could have images of the underwater, the situation underwater there. Here we have a view of the farm, control place, research scientists in Naples, and the images from the island. And also here, where there is a situation underwater with a lot of mud carried out by glaciers and so on, you see that there is, in any case, some life. These are sea anemone, probably biologists can say that. But when you work in polar regions, you cannot avoid to handle action value. Here we are in Antarctica, and I mentioned that we carried out from the headquarters of the Siena Group, the remote teleoperation, internet-based teleoperation of the army. The day before of this demonstration, I was with my colleague of mine. We were in Rome to handle these operations from Italy. And we had no contacts with our colleagues in Antarctica. And so, of course, we started. We were worried, and we also said, oh, probably they are joking, they are doing nothing, what are they doing, why they don't connect to us. They didn't call us because the situation there was this one. Because there was this katabatic wind from the inland towards the sea. It was more than 100 kilometers per hour, and basically fully destroyed the tent and the camp on the peptides. In any case, one day they were able to mount the camp again. You see which was the situation of the tent. Lastly, the wind didn't move the other wheel that weighed 500 kilos, and it was safe, and we could use it one day, the following day. So, this was a good lesson. And we said, okay, we have to move to use a tank to a container. At least when we are in the proximity of the station, and we can transport the container there. So, during the following campaign, we used different logistics with containers instead of tanks. And so in 2003, we had this campaign where we used the logistics to build, to make holes in the peptides. This is the one that we use it when we are in the proximity of the base. But when you want to work on the remote site, you cannot move all these devices with an helicopter, and you need to use the hand drillers that can make holes right here. We use the idea of the concept of Antarctic detection. Basically, the cruiser was a basic chamber, and the scientists could pilot the vehicle, see the place, that's a place saying, okay, I'm interested to leave here for 44 hours, 24 hours, the basic chamber. The vehicle released the chamber, yeah, you see the image, was recovered, we left an acoustic period on the chamber, the slab, and one day they were able to go there and travel. And they were able to perform it about 10 times during this campaign. And the slide is now in our lab. So it works. And the one question is, why we didn't balloon because we were below 3 meters of peptides. It was not possible to use conventional technologies for pollution. Now we move to when Charlie was the first American people working in the anywhere in the decision project for the study of the sea interface. And what he did was the integral sampling of the sea surface microlayer and immediate subsurface water with the other like sea. What was and here we worked again in the Ketis Bay. So basically now you see the USB where before there were the containers. Because usually towards January, January 1, the peptides breaks or is moved away by the sea, and you can access on the surface itself. What was very impressive for me is this. This is the replica of the out with the area like cylinder, so coming from the sea surface control. And the other one collected with the power about 30 centimeters below. So you see that the concentration of particles is quite higher on the sea surface control. And the vehicle is a camera with pellets, and during this mission, we didn't use rockets, and then we introduced them later and complete. There were also some other problems because the scientists were interested not only in organic samples, but also in organic samples. So we had to avoid that the people sample itself. So the hull was created with retina, and before the campaign we tested this fiberglass painted with this retina lady in a tank for 1 month and to see that it didn't pollute. So after 10 years, we went again to Antarctica.
Togli il microfono un momento, togli il microfono un momento perché hai un problema di acople nella trasmissione. Segui hablando parla senza microfono.
Okay.
Un attimo. Andiamo sempre.
Okay, so I can move on. As I mentioned you before, what we had was there is this strong interest by scientists in understanding how Antarctic silverfish reproduce. And you see, as you can see in the movie on the top right, eggs and larvae in the peptides. But we never saw how they release the eggs there and when. But in any case, it was interesting to sample them and so on. So for doing that, we adapted the mini ROV video array with a pump to suck this larvae, and it was possible to do it in the creative with the adaptation of the commercial of the shell. And we could do it with the robots instead of with the divers. And in these conditions, it is particularly important to use robots because water is so cold. Divers have an autonomy of half an hour. Sometimes things could go very badly for the divers. It's very dangerous to make elections in these conditions. And so robotics is a solution, and this could allow the collection of a lot of samples. Another thing that we tried during that campaign was in this project where we developed the Proteus ROV, the goal was to observe and understand the evolution. And we also developed something to have a persistent monitoring of what was going on underwater during the whole year. So the solution that we proposed was to mount a pole in the pipeline. Now you see, which is behind the driller, when you are far from the base. So it is difficult to make holes, and this is the reason of the size of our ROV of 35 centimeters. So we mounted it, we left the pole there with a vertical wind generator for providing batteries that we left inside and below the snow. And we left this pole with camera collecting images underwater for 1 year. We checked which were the areas where pressurized didn't broke during previous years and so on, but Murphy law exists and it broke. So the system started to shift in Antarctica,